Chairman, ladies and gentlemen, very good afternoon. I hope you are not angry to me that I have my presentation in English. I think it's better for both of us. This morning when I arrived in Ezeiza, I thought it's good that I have in my luggage a presentation which brings some hot air from the African continent, because I was really surprised about these 3 degrees in the morning. I left Austria yesterday evening with 35 degrees, so it was a kind of shock for me. But I felt like last year for this African project. I will tell you some aspects about, in particular, about the preparation of this project of crossing the Suez Canal in Egypt. And I may ask you, probably most of you don't know what happens on 6th of August last year. It was the big opening ceremony of the extension of the widening of the Suez Canal. It was a national celebration in whole Egypt with a very big event on the top President Al-Sisi, and to see to receive some ideas about the dimension of this project. So the whole volume of extending or of expansion of the Suez Canal was in the range of $8.5 billion US. The length is around 70, a bit more than 70 kilometers of additional canal, a second canal for the Suez Canal, giving the chance to increase the capacity and on the other hand to shorten the transition time from A to B or from north to south. The interesting fact of this 8.5 billion US were entirely financed from the people of Egypt, and all this financing was done within 1 week. So they collected with a kind of special procedure this money in the Egyptian society within one week. So this is really an astonishing fact. And here you see this location, the Mediterranean Sea. So Europe is somewhere north of it. The Suez Canal in this location and the Red Sea. And there are, you see this green shaded area of the delta of the Nile River, densely populated, densely used, in particular also for agricultural use. So Egypt now has around 100 million of inhabitants, so a big demand also to feed the own population of Egypt. So any extension of for the future must be on the eastern side, on the Sinai side of this canal. So there are 2 locations were defined to underpass to cross this Suez Canal by means of a system of tunnels. One in the north, near Port Said, near the entrance to the Suez Canal, and one in the middle in the so-called city of Ismailia. Our project was this one in the north, in Port Said. So the location of this, where there is a kind of a Y shape of the canal, so to underpass the Suez Canal more or less perpendicular, to give accessibility to this future industrial land. And to give you another interesting number, so the space for this future developed land will be around 460, not acres, 460 square kilometers. So also you see these huge dimensions which are under performance here in Egypt. The customer was the Egyptian Armed Forces, the Military Engineering Authority, contractor, the 2 biggest construction companies of Egypt, Orascom and Arab Contractors. The contract was a so-called remeasurable EPC. Construction time started in 2015. The opening shall be in around 2020 or 2021. The approximate contract volume will be around $2 billion for this project in Port Said. The initial situation was very interesting. The project, of course, you see this number is of high national interest. That means on this project was a big time pressure and, of course, high expectations, in particular from our customer and also from the president of Egypt. The representative of our customer were the armed forces with generals from the armed forces, so also a particular situation to handle generals on a daily basis. The contract was given to us in a direct order because of confidential reasons, and it was a remeasurable EPC model. The project started on the basis of a feasibility study performed from a consortium from Spanish consulting companies in 2013. The result from this feasibility study was the definition of the alignment in the horizontal and in the vertical direction. Also, the colleagues proposed the technical and the operational concept for this project. They proposed the construction concept, means construction by means of slurry shield TBMs, and they also defined that the main construction site should be on the eastern side of the canal, which also brought us some difficulties I will state a bit later on. If we look a bit more into detail to our project, you again see this Y shape of the canal, this future industrial land, and this more or less perpendicular crossing of the canal with a double tube motorway tunnel and the proposed crossing of the canal with a double track railway tunnel. So 3 tunnel tubes under the Suez Canal indicated here. This all on the basis of this feasibility study, the proposed site installation. Very interesting point, the road tunnel underpassed, undermined from this railway tunnel. Here you see the alignment of the railway. Here you see the road with the first connection to one existing highway and the option with the link to a second highway a bit more to the west. Some figures, some numbers from the tunnels itself. The road tunnel, the proposed length around 3.6 kilometers, 2 lanes, 2 walkways, a gradient with a maximum 3.3%, which is very common. A railway tunnel with a length a bit more than 3 kilometers. As I told you, double track system, track distance 3.5 meters, and the maximum proposed gradient of 25 per mil, which is very steep for a properly performing railway. The clear height of 5.5 meters, excavation diameter similar for the railway tunnel and for the road tunnel with roughly 30 meters. The maximum transition radius with 3,000 meters. Also in combination with this, you see here the numbers, so that led to around 10 kilometers of mined tunnel length with these 3 tubes, but additionally around 3,000 meters of cut and cover and ramp sections for these 3 tubes, cross passages, shafts, and a very interesting number because of its dimension, in particular for the support of the cut and cover and ramp section, roughly 500,000 square meters of diaphragm walls with maximum depths of 100 meters, which is a really uncommon number, I may say also worldwide. Very interesting was, as I stated before, that in the very early stage of this feasibility study, also the construction system was defined, and it was defined that the construction should be done by means of slurry or mixed shield DBMs, and that led to the decision that the Egyptian government purchased this separately from the contract. So the Egyptian president purchased four, let me say, for DBM units, means the DBM itself, the slurry treatment plants, the molds for the segment fabrication, and all the periphery for the both project in advance of, let me say, of a proper design, which led to some difficulties in the part. That led to the situation that, of course, the delivery date, it was some Herrenknecht DBMs, were defined in advance. So we had to schedule our preparation works to keep these delivery dates. It was also defined indirectly that there shall be performed a single shell lining concept. We are talking about 60 meters depth under the Suez Canal, means around 6 bar of water pressure, which is not that easy. Also the molds were already designed, so that means the geometry and the thickness of the segments was predefined very early, and of course also the performance rates for the excavation indirectly because of the dimensioning of the slurry treatment plant and so on. Very interesting situation, which is not very common and should be avoided in general, but as in our case, and not only in our case, you can find these things or these situations worldwide. All these decisions has been done without having a proper knowledge of the relevant design parameter, means without having proper knowledge about the ground conditions, the behavior of the groundwater situation. On one hand side, on the other hand, the problem in case of this EPC model was, so we had to make our design to define the bill of quantities. On the basis of the bill of quantities, we were able to sign the contract, which is a period of roughly 1 year. So that means we had to work roughly 1 year without having a contract, only with dealing this project with some advance payment, which is also not very comfortable for the joint venture. As I have been involved, so I studied this situation, which was not very beneficial for the joint venture. So, of course, it was the requirement of an immediate project analysis. On this basis, we defined the main risk, the main influencing risk. It was not possible to change the whole project, but the main risk in particular in relation with the ground conditions and design, and also in relation with site operation, logistics, and also in particular here in Egypt in this situation with safety and security on site. So we designed very simple and so-called ABC plan and tried to solve all the main targets, the A targets, and then if they are solved, probably some B targets, and the others we have to live with some problems over the whole project. So not a very very comfortable situation for us. And also, of course, we have to convince our customers, our generals, that they follow our ideas, our impressions to change at least in some relevant aspects, the boundary conditions for this project. Coming to the main aspects, to the ground conditions, so immediately we started with some additional ground investigation program. So you see very high number of additional investigations, around 40 CPTU tests, around 30 core drillings, in combination with with a extensive laboratory program with some geophysical monitoring and some field tests. Also, one very essential aspect was not only to look for the quantity for some additional investigations, also to look to the quality. And you see in these conditions, we performed really from that point on a high quality level, really to be sure that these probes, these samples that we get, this knowledge, we can really rely on this, and because of really proper workmanship. Coming now to the general geological situation, here again you see our project area, the Nile Delta, and all these you can imagine this big Nile Delta. In all these regions there is more or less pure clay, salty pure clay. You see a typical cross-section from the regional geology. So you see these clay formations here, and described a big sand formation in between. Unfortunately, because no proper investigations have been performed in advance, all the project based on the existence of this, let me say, around 20 meters thick sand layer, which in our area didn't exist. So we had to change completely because we found out that we have a continuous uppermost sequence of around 40 meters of weak, more or less pure clay to deal with our construction. So in the longitudinal section, you see we have these clay, these silty clay formations down to around 40 meters, and then starting these sandy formations in depths lower than around 40 meters. And also then we have to look for the vertical alignment to locate our alignment not too shallow in these clay formations, because in particular of these problems with the canal itself, to go deeper and to locate this in this stable sandy layer. So corrections as I told you, in the vertical and horizontal alignment. To give you some impressions about this material, so it was more or less pure clay, muddy, salty, wet clay, and also you see some soil properties, mainly very, very weak clays down to 36 or 40 meters. In this area, we have to construct our cut and cover sections and to reach this level of the sands with the tunnel. So soft clays, high thickness, high water content, high salt content. If I talk about high salt content, it amounts something around 3 times higher than the original salt content from the seawater. So very, very high salt content, of course, also in addition very high organic content. So really bad conditions to work with. If you do not rely on not only rely on the results of the laboratory tests. Also, we decide to make some large-scale load tests. One of these blocks is roughly 1 ton with around 70 centimeters edge length. If you compare this, then you see within some days you have settlements because of this load reaching 20 to 25 centimeters. So you see the conditions of our ground where we should start with our construction. So what were the consequences? And of course, which countermeasures were able to do within a short time? So first, we had to develop really a consistent, a coherent site layout, dealing also with these weak ground conditions, because also from the site installation itself, we have some big loads we have to handle this. We had to make modifications in the, as I told you, in the horizontal and vertical alignment. We had to find out really a practicable foundation concept by means either by embankments and on the other hand by means of pile foundations. We had to discuss which in particular because of these high salt contents, which parts of our construction can be permanent construction parts and which one are only for temporary use. And also we had to understand that there are some questions which we cannot solve, at least in the existing time. So coming back to the original layout, you see the road crossing, the originally planned railway crossing. So in relation to the alignment, we completely changed the railway alignment with the benefit that we avoided this underpassing, this crossing from the railway tunnel under the road tunnel. You can imagine in this weak ground, this big interference between the two structures. And of course, from the railway point and from the operational point of view, we had improved connections to the existing railway lines. And also, we smoothened the vertical alignment. We decreased the gradient from 25 to 20 per mil, which is beneficial for the future operation of this railway tunnel. For the road tunnel, no major changes were done in relation to the alignment, because we enforced backfilling in total around 1.5 million tons of backfilling before we can start with installation on site. Here you see this system, first layer of backfilling, 3 layers of geogrid, total reaching a depth of 2 to 5 meters. So the soil mechanic engineers will know what happens. You easily see it. You bring additional load on it, and immediately you start with the settlements. You clearly see it. Water was pressed out of the ground, and of course also settlements occurred. I showed this picture. This was expected, but of course it's interesting. So if you do this, if you have some, let me say, some flexible situation, and in parallel you have to do some pile foundations which are stable, so you have to deal with the differential settlement between these two structures, which was really not very easy to deal with. Coming back now to the pile foundations, so all structures which were heavy, which were sensitive to settlement, had to be founded on piles to have good performance rate. We use two different systems of pile foundations. Piles, precast piles, which we produced directly on site by ourselves, and pipe piles as an additional system, for instance, as you see here for the future segment factory of all the silos and batching plants on site. To give you an impression about the resistance, or better to say the weakness of this, or non-existence of this ground, a very short video sequence about installation of such a pile, and you see the performance rates. It's like in weak butter. So almost no resistance, down to 36, 38 meters. So we applied hundreds. I think the rough number was around 950 piles only for site installation. Another interesting job for this project was in combination with these cut and cover and ramp sections. So, for instance, here, these ramp sections, so all this stroke had to be founded on barrettes, on piles, to avoid settlements for the final structure. You can imagine that to deal with this, to be watertight, to have proper connections here is not a very easy job. For the cut and cover section, of course, we have the same situation. We had these foundations by means of diaphragm wall. In the original design, it was proposed to have this diaphragm wall as a permanent structure, as part of a permanent structure. So we had to convince our customer that this will not work, because sooner or later, by means of cracks, we will have the corrosion and we will have negative effect to the final structure. So a lot of additional quantities we had to construct this in advance, and in the protected area between these diaphragm walls, we were able to construct this box. Also very interesting were these shafts, these launching shafts for the TBM itself. To give you also a number, the diameter here was roughly 25 meters, so a length of 100 meters by 25 meters. If we have 3 tubes by 2 portals, means we have to construct 6 of those big shafts, all surrounded by diaphragm walls with steps down to 50 and 60 meters, really to reach stable ground and also to reach dense ground, to avoid water ingress from the bottom, to avoid uplift and problems during construction for this shaft. So very interesting situation, and you see in the construction stage also the dimension of one of these shaft cells. So this was the eye. Then later on was the breakthrough for the TBM itself. I give you another interesting impression. So I always call it the ballet of our equipment on site, because all of this, and I'm coming back again, all this situation was because the customer expected us to start with construction on a not existing or not reliable basis. So all was mixed up, and we have to do investigation in parallel to design, in parallel to construction, with a high time pressure. Means you have a very nice combination of big equipment here on site, dealing a bit like a ballet in the opera. You see what's going on. We have 12 rigs, 12 diaphragm wall rigs, I don't know, some tens of excavators and something like this, all must be coordinated or had to be coordinated or had to be supplied in a location which is not very easy to operate. And of course, we were not completely satisfied with the layout of the DBM system. So also Herrenknecht defined in coordination with our customer a DBM system on a insufficient knowledge of the ground. So having now the idea what's really to be expected, so in parallel to the manufacturing process of the DBM itself, we have to deal with Herrenknecht in Germany to do some modifications in the slurry stream, in the pumping rates, in the layout of the slurry treatment plant. So you can imagine if you are constructing the slurry treatment plant on site and in parallel, you have to talk with the technical office with Herrenknecht in Germany to do some modification. That is really a very unfavorable situation. Okay, coming to another point, to this predefined location of our site layout on the eastern side of the Suez Canal, on the Sinai side of the Suez Canal. So this was the virgin situation when we entered the site. So very impressive, the ships passing through the desert. There was almost no accessibility. There was no supply infrastructure, means no water, no roads, no nothing, only sand. And of course, also in this in this feasibility study, there was no sound site installation concept. There was only the definition site installation has to be there without thinking about all these aspects. So really very unfavorable situation. On the other hand, we knew that there was a really nice bridge, but because of safety reasons, because of these terror attacks which occurs from time to time in Egypt, this was strictly prohibited to cross this bridge. So all our transports have to be made on these small car ferries crossing the Suez Canal. So, and you can easily imagine that the capacity of your transport, of your supply of logistics is a bit limited. Also, we had to find out some countermeasures to deal with this situation, because we were forced to perform. So that means we tried to avoid that most of this supply must not cross the Suez Canal. Means we looked for some aggregate quarries in the Sinai Desert, which is from the technical point of view not very easy, and then it's also this region where the IS terrorists are operating, so also from the safety situation a not very comfortable situation. All our cement had to come through a tunnel which is 200 kilometers away in Suez, crossing the Suez Canal. So all our cement transports have a transport distance of roughly 400 kilometers, and the remaining transports which have to cross the canal, okay, we have to deal with these delays, which could be hours or days. On the other hand, we put a high pressure on our site installation itself to accommodate our persons there, to locate our site offices there, that also the people and our staff has not to cross the Suez Canal that often. The security situation is very precarious there. On the Sinai, as I told you, is operating the IS terrorists. So we were in this heavily protected security zone of the Suez Canal itself. means that everybody of us has to have a high security permit, really to be allowed to enter these zones, which is not that easy if you have around 2,500 persons of staff, all these administrative agendas to deal with. On the other hand, one slight but also important aspect, it's not allowed to have any air traffic in the vicinity of the Suez Canal, also against terrorist attack. So that means also if you have an accident on site, it's not possible to bring this injured person out to a hospital by means of a helicopter. So you have to deal it with your local hospital on site and hope that you can handle this, also these injuries on site. They were installed in coordination with the Army, a lot of security checks. We had to work out a specific transport concept in detail, giving us the flexibility, giving us also the sufficient capacity, but also keeping us in a safe situation. We had to surround all our site, which were thousands of meters, by means of a concrete wall to be also safe against shot attacks from probable terrorists. Also a very interesting situation. And from the Sinai war in the 70s, also all this area is full with remaining mines. So any operation in, let me say, new land, first you have to coordinate this with the armed forces to receive this so-called mine certificate that this area is really safe. So really complex conditions. Normally you should think about these situations and you should solve these situations before you ask a contractor to start with such a project. So coming to the conclusion, again, you cannot say it too much. A sound basis is essential for any project. So I miss this all over the world, that you start too early and with insufficient knowledge, also in big and in particular in big and complex projects. So the relevant factors influencing your technical, financial, and also in our case your safety aspects, they must be considered and they must be solved in advance of starting such a project. For this you need time. And if you don't spend this time in advance, you will lose it later on. So better to work it out in advance of this. And in particular, the aspects regarding constructability, site logistics, also for such complex projects, independent if they are in the desert of the Sinai or probably in the Andes, they must be considered to a relevant basis in advance of such a project. The EPC model was proven to work in general properly, but you cannot mix up all these phases. So if you do it really as it is stated, it's a really proper working system, because it gives the possibility that the experience of the contractor influences the project. But of course, a structured design and investigation process must be done in advance. And as it has been in our case, to transfer risks to the contractor sphere, from my point of view, is not appropriate. The DBM system is part of the project, so to deal this system independent or in parts independent from the project will lead you to these problems, as I stated, or as I spotlighted some of this. Independent from this, nevertheless, we solved the main problems in due time. So the delivery schedule of the first DBM was not influenced. We were flexible and powerful enough to keep this date with December of last year, and the main preparatory works were completed in due time. That also let me say, the expectations of the President of Egypt was not influenced too much from our, let me say, performance on site. I have really good look back to this project. So meanwhile, I'm on another continent. It was very interesting. I think the best lessons to learn are from projects which were not running that smooth as you always read it in the papers or in some as you hear in some lectures. So I learned a lot of this. One, coming back to the first slide, also one impression was really very, very large for me. So through the Suez Canal is passing 8% of the worldwide freight traffic. So, and I understood the first time in my life the importance of transcontinental freight and the importance for the economy of each of these countries. I see a similar situation here in Latin America, and I think this will be, and also Alexandre said this will be one of the demands in the future for you here in Argentina and in Chile to solve these transcontinental transport demands, because the Panama Canal alone is not enough. And allow me one remark, it will not be possible to deal this only by means of truck transport, so you will need a proper working freight rail, otherwise you will not be able in the future to deal with these transport quantities. Thank you very much for your attention.